If you look at young children, they're in some sense question-asking machines. They want to understand how their world works. And when you look at the nature of the questions, understanding their world is a perfect fit for science.
We wanted something that had flexibility and freedom, but also provided teachers with a little bit of guidance.
So working with teachers about the kinds of things they were already doing in their classroom that would count as science learning for young children, and helping them to think more deeply about it and to change their practice around science, to think more about concepts and the kinds of concepts children were learning, and then think about the kinds of activities that they could do to support children's learning of those concepts.
So we thought that starting out the year talking about senses and making observations would be a good idea, because observing and describing is a critical science practice. From there, we started talking about things that are living and things that are non-living. Children get this idea that living things move, but then there are non-living things that also move. Cars move. Kids seem to understand that cars, even though they move, they're not alive. So they could have wonderful discussions about what is the difference between something that's living and something that's not living. In the next generation science standards, they have these three aspects. They have science and engineering practices, cross-cutting concepts, and disciplinary core ideas. Cross-cutting concepts are these concepts that you see throughout all domains of science. For example, patterns. We see patterns everywhere. You know, there are patterns in traffic lights, and traffic lights are actually really important to these children because they live in a city where they walk around and pedestrian safety is very important. Traffic lights always have the same pattern. It's green, and then the light is yellow, and then the light is red. Another cross-cutting concept is structure and function. And that has to do with the idea that the structure of an object has an effect on how it can function out there in the world. A wooden block, if you put it standing up on its tall end, it's not very stable and it falls over. It doesn't function very well as a foundation for a block structure. But if you put it down on its flat side, it functions as a wonderful base. Another concept is stability and change. The idea that some things are very stable and unchanging, and other things change constantly, and they change at different rates, and they change in different ways. Another cross-cutting concept is cause and effect. When children are engaged with phenomena of physical science, the effect follows the cause pretty much immediately. You know, if children let go of a marble at the top of a ramp, it rolls down the ramp. They can see that it happens right then. And if they lower the ramp, they make it not as steep of an incline, the marble moves more slowly. So then they can construct this causal relationship between the height of the ramp and the speed that the marble rolls. It's pretty direct, it's very observable, so children can connect causes and effects. Using these cross-cutting concepts became a way that teachers could connect the curriculum.